So in this example, we will design a 2-bit counter using finite state machines. Okay. So in this 2-bit counter, we will have a reset input to initialize our counter to 0, and we will have 2-bit counter output. Okay. So in a way, I have a finite state machine with 2-bit counter. So I will have a clock signal and a reset signal here, and I will have a 2-bit output. Let's call this Y. Okay. So how does this counter will work? So we have this clock signal, right? Let's say we are using the rising edge, and this is my clock. And then I will also have a reset signal. Let's say this is an active high reset. So initially it is 0, let's say, and it will be high for some times, and it will be low. Assume this is a synchronous reset, okay, and then we will have our output Y. So initially I may not know what is my output until the reset, okay. So this is my output Y, and I don't know what is the value until here because I haven't resetted my circuit. But after I got a reset here, why? Because my flip-flops are working on the rising edge. So they are positive edge triggered, and then I will initialize my state to be 0 here. So this will be 0, and on the next clock edge, then my output will be 1. It is counting, right? So this is a counter, and on the next clock edge, my value will be 2. On the next edge, it will change to 3, and on this edge, it will go back to 0, right? Because a counter is a 2-bit counter, it will count from 0 to 3, and then it will go back to 0, and then it will count again. So this is what we are trying to do. Okay, so in this case, if I look at this timing diagram, what do I see? I have 4 different states, right? I can draw my state diagram. So this is my S0, and I will say this is 0, 0. And I have a state of S1, 0, 1. I have a state of S2, 1, 0. And another state, S3, 1, 1. Right? So I have an input of reset. If reset, I will just show this like this, okay? So this is my reset signal. If there is a reset, I will go to S0 state, right? This is coming from any state, right? I could have just show it like this as well. And this one, right? So if the set is 1, I just go to S0, 0, and my output will be also Y is 0, right? So this is the only input I have for all the other cases. So if I am in S0, the next clock cycle I will go to S1, right? So there is no condition on this one, right? So in the next clock cycle I will go to S1, and if I am in S1, the next clock cycle I will go to S2. And then here I have an output of, so in this case actually this is a Moore machine, and my outputs is only depends on my states. And in this case, instead of writing my states number here, so this is a Moore machine, and my states will also give my outputs. So in this case my output will be 0, 1, okay. So in each state I have an output, and I will just write it here. In S0 I will have my output 0, 0. S1 my output will be 0, 1. In S2 my output will be 1, 0. Actually in this case, just for this example, my output is equal to my current state, okay. Y will be 1, 1. So then since this is a Moore state machine, I show my outputs inside the states, okay. So in the Moore we show the output inside the states. So if I am in S2, I will be going to S3, so next clock cycle, and if I am in S3 I will be going to S0, right? So this is my state diagram for 2-bit counter with reset signal.